which is the limit as x approaches 10 of, so we have to evaluate this x squared minus 1 all over x plus 1, right? So this is very, very simple because I'm giving you simple questions. But your assignment will be tough questions. It will be tough questions. Right. Alright, so solution. You can see that this one is x squared minus 1, this one is x minus 1. Now this one, that's difference of 2 squares, so I can do something there. So which is the limit as x approaches 1 of this one will be x plus 1. Then x minus 1 all on x minus 1, right? This one, x squared minus 1 is the same thing as what? X squared minus 1 squared, so which is the same thing as this. This one can take care of that, right? So I can say that the limit as x approaches 1 of what? X plus 1, right? So the limit as x approaches 1 of x plus 1. So I can move further and say that the limit as x approaches 1 of x, then plus the limit as x approaches 1 of 1. So I'll plug in what? 1 into the what? The x value place. So which is 1 plus the limit of a constant is what? The same constant, which is 1. So 1 plus 1 gives 2. So we are done with the type 2, which is indeterminate forms of what? Limits. Indeterminate forms of limits. So you have to do further simplification before you get that indeterminate forms of limits. So when you plug in the what? The x value, you can get what? 0 and 0, which is very difficult to do that. So you have to do the simplification. Alright, so take this as your assignment for indeterminate forms of limits. So home link. The home link. So I give you 3 questions here. So they said evaluate the following limits. Evaluate the following limits. So we have the limit as x approaches 1 of x cubed minus 1, x cubed minus 1 all over x minus 1. Then to the limit as x approaches 2 of x cubed minus 8 all on x squared minus 4. Then 3 and 3 okay, let me mix it with what? The substitution to school. Then you have to try them. They're all good for your health. Yeah? The limit as x approaches 1 of x, you take the square root, then x squared plus 1 all on x plus 1. And 4. Okay, let me end here, then you go and get next this thing. Look for more examples than you solve it yourself, man. Yeah. So look for more examples and you solve it yourself. Right. Alright. So that's how you copy it, right? Alright, so let's proceed. We are done with the type 2 and the limit of functions at a point. So let's move to the type 3. Type 3. Type 3. We are moving to the type 3. It says evaluating limits that contain sets. So this time around, we are talking of sets here, right? Evaluating limits that contain sets. Evaluating limits that contain sets. So this one is type what? 3. That's the type 3. So we've done type 1, we've done type 2. So type 1 is direct substitution. Type 2, indeterminate forms of limits. Then type 3, it contains what? Sets. So limits of functions at a point. Still at a point. But this time around, they give you the function that contains set. But that limit will approach what? That limit you find for the limit as x approaches that point. So now, listen here. If the limit is initially indeterminate, so now, you cannot do the direct substitution, right? When you get this, which contains what? Sets. You cannot do direct substitution. So when it contains sets, then you have to do what? Further what? Simplification. So you have to do further what? Simplification. You have to do further simplification. So this one, okay, I can say that type 2 of 1 because it falls under that indeterminate. Because when you plug in or when you do direct substitution, you go back to what? The indeterminate, which is 0 on 0. Right? So this one I can say type 2 on 1. Right? Or we can give it a name type 3. So it's cool. So if the limit is initially indeterminate, multiply the numerator and denominator by the conjugate set and then divide the numerator and the denominator by the common factor. Again, if the limit is initially indeterminate, multiply the numerator and the denominator by the conjugate set. I believe you know conjugation. You've done sets, that's properties of sets. So if I have 1 plus square root of 3, what will be the conjugate of this 1 plus square root of 3, which is what? 1 minus what? Square root of 3. If I have 2 square root of 3 plus 3 square root of 5, what will be the conjugate of this? It will be 2 square root of 3 minus 3 square root of 5. If I have 3 minus square root of 5, what will be the conjugate? It will be 3 plus square root of 5. So that's the conjugate we are talking of here. So I said, multiply the numerator and the denominator by the conjugate set and then divide by the what? Divide the numerator and the denominator by the common factor. As you proceed, however, do not multiply out the set and the non-set part, as this will prevent you from finding the common factor. So now, we have this. We have this. We have this. So, let's start with examples here. I believe you understand what is going on. When you do examples, you understand what I'm saying here. Alright, so let's proceed. Let's proceed. Examples. Examples here. So question 1. So let's start. Evaluate the limit as x approaches 3 of x minus 3 all on 1 minus square root of 4 minus x. So we have this. You have to evaluate this. Now, let's see. When we plug in 3 into the numerator, we get what? 0, which is 3 minus 3, which is what? 0, right? Then also, we have 1 minus square root of 4 minus x. Wherever you see x, then you plug in 3, we have what? 4 minus 3, which is 1. Square root of 1 gives what? 1, right? So 1 minus 1 is what? 0. So now here we get 0 on 0, which is indeterminate, right? So now what do? We don't do direct substitution, but now here it contains sets here. So we have to multiply the numerator and the denominator by this, the denominator, its conjugate. Alright, so let's see solution. The limit as x approaches 3 of x minus 3 all on 1 minus square root of 4 minus x. So times, what will be the conjugate? The conjugate will be 1 plus square root of 4 minus x. Mind you, only this will change to plus, not this, not the inside. All on 1 plus square root of 4 minus x. That's that. As you were doing with the sets, properties of sets, how did you do properties of sets? You were what? When they tell you to rationalize the set. So we have to what? Rationalize the denominator. In rationalization, that means you are removing the irrational set to become what? A rational value or a rational variable, right? That's what we are talking of here. So you have to rationalize the denominator. So you have to rationalize for you to understand it that way. Let me put it that way for you. So you have to rationalize the denominator, right? To clear off what? The said aspect, right? So now, let's proceed. So now we have what? X minus 3 times this. That's multiplication of fractions. So x minus 3 times this 1 plus square root of 4 minus x. Then this 1 minus square root of 4 minus x times this 1 plus square root of 4 minus x. Right? So let's see. Watch here. The limit as x approaches 3. So I have what? X minus 3 multiplying 1 plus square root of 4 minus x all over 1 minus square root of 4 minus x, which is multiplying 1 plus square root of 4 minus x. This is very simple. So we can see as that. So now, watch here. Don't cancel this by that. You go back to cos 90, that's 0. So you go back. So please watch very carefully. We said that don't multiply, but cancel out what the common what factor. Watch here. Now 1 minus square root of 4 minus x, then 1 plus square root of 4 minus x. Now we can see that this and that, right? They are difference of two squares. True of us. True. So I can see that the limit as x approaches 3 of this x minus 3, then this 1 plus square root of 4 minus x all over this. I'll take the negative aspect, which is what? 1 squared minus square root of 4 minus x, or what? Squared for that. Right, so now you can say that the limit as x approaches 3 of I have x minus 3, which is 1 plus square root of 4 minus x, all on. Now this cancels the square root, right? So I have 1 minus 4 minus x. You have to be careful with the negative here. It's affecting the elements inside the bracket, so you'll be very, very careful with that. So I have the limit as x approaches 3 of x minus 3, then I have 1 plus square root of 4 minus x all over. I have 1 minus 4, then plus x as that. Right, so still we can proceed as the limit as x approaches 3, then x minus 3, then 1 plus square root of 4 minus x all on 1 minus 4 gives you minus 3, right? So we have minus 3 plus x, and minus 3 plus x can also be written as well, x minus 3, right? So we have this. I believe you understand. Because minus 3 plus x can also be written in this expression or this form. That's x minus 3. We can cancel out. This one cancels that. So you see we can cancel out a term inside. Okay. So I can continue here. It's very simple. You can watch. Very, very simple. So we can continue here and do the limit as x approaches 3 of 1 plus square root of 4 minus x. That's that. Right? So now, if you have this, then we can say the limit as x approaches 3 of 1 plus the limit as x approaches 3 of the square root of 4 minus what? X. Forgot. So now here, we can say that the limit of a constant will be what? The same constant plus, now the limit as x approaches 3 of this, when you see x, you plug in what 3, so 4 minus 3, which is 1 plus square root of 4 minus 3, which is 1 plus square root of 1, which is 1, so I'll get what? The answer, the limiting value is 2. Right. So it's very simple, it's very simple. So always you have to check the question. It's very simple. It's very simple. It's very, very simple. Very, very, very simple. Alright. Question 2. Question 2. Evaluate the limit as x approaches 4 of square root of x minus 2 all on x minus 4. So this. The limit as x approaches 4 of square root of x minus 2 all on x minus 4. So this one here, we have a set at the numerator. It's not always you can rationalize the denominator, but you can also rationalize the numerator as well. You can rationalize the numerator as well. So not always. So now here, I can take it as the limit as x approaches 4 of square root of x minus 2 all on x minus 4 times, I'll get what? The conjugate will be what? Square root of x plus 2 all on square root of x plus 2. Right. So now, we can proceed as that. Which is what? We multiply the limit as x approaches 4 of, we have what? Square root of x minus 2 then times square root of x plus 2 all on x minus 4 times the square root of x plus 2. Sharp. Very, very simple. So the limit as x approaches 4, right? Now, for the numerator here, we have square root of x minus 2, then square root of x plus 2, they are multiplying, right? So now, if they are multiplying, here is negative, here is positive, so that means difference of 2 squared can what? Can work. So I'll take what? The negative side, which is what? Which is square root of x all squared minus 2 what? Squared. All on, so I have this x minus 4, then square root of x plus 2. So x minus 4, then square root of x plus 2. So the limit as x approaches 4 of this one cancels that. So I'll get x minus 2 squared, I'll get 4. All on, which is what? X minus 4 square root of x plus 2. So I have this. Right. So we can see that this one can take care of that. So I'll get the limit as x approaches 4 of, yeah, I'll get 1 all on square root of x plus what? 2. Right. So we can take it as that. So we can take the limit as x approaches 4 of 1 all over the limit as x approaches 4 of what? Square root of x plus 2. Right. So with this, I can proceed again and say that the limit as x approaches 4 of 1 all along the limit of square root of x as x approaches what? 4. Right. Then plus the limit as x approaches 4 of what? 2. Very, very simple. So, let me clean this place. So, we can proceed again. And say that the limit of a constant as x approaches 4 is what? 1. All on the limit as x approaches 4, this square root of x, we just plug in. So we get square root of what? 4. Then plus the limit of a constant as x approaches 4 is what? 2. Right. So we get this, which must be equal to 1. All on square root of 4 gives what? 2. Then plus 2, which is equal to 1 on 4. So this is the limiting value. 1 on 4, which is 0.251. So let us take last example, right? Yeah, let us take last example. Then I'll give you works to try. So when it involves limits, this is how you move the book or the question. So I have the last example, which is the third question. It said evaluate the limit as x approaches 9 of square root of x minus 3 all on x minus 9. So solution. So we get this by rationalizing the numerator, right? Because that's where we can locate the set. So the limit as x approaches 9 of square root of x minus 3 all on x minus 9 times square root of x plus, because the conjugate of square root of x minus 3 is what? Square root of x plus what? 3. So now, what do we do? Hey, look at what I'm doing here. Show you. So I have square root of x plus 3. So the numerator and the denominator here. So now, we can see that the limit as x approaches 9 of this one we multiply, which is square root of x minus 3 times square root of x plus 3 all on x minus 9 times square root of x plus 3. Sharp. So we move as that. So the limit as x approaches 9 of the square root of x minus 3 times the square root of x plus 3, all on that. Negative, positive, they are the same, but here it changes, negative and positive. So we can see that is difference of what? 2 squared. So we can proceed as that, which will be what? The square root of x, or what? Squared minus what? 3 squared. Right. All on, we have x minus 9 then square root of x plus what? 3. So we have the limit as x approaches 9. So now here, this one takes care of that. So I get x minus 3 squared gives what? 9. Right. All on x minus 9, then square root of x plus 3. So this one cancels that. So I get the limit as x approaches 9 of 1 all on square root of x plus what? 3. Right. So we proceed by taking the limit. Then we do direct substitution. So we are done with our simplification. Right. So we move as the limit as x approaches 9 of 1 all on the limit as x approaches 9 of square root of x, then plus the limit as x approaches 9 of 3. I believe you know that because I have to take the whole of this. When you are done, you apply the limit for each of what the terms there, right? So now I can clean this side, right? So we move as the limit of a constant gives what? The same constant, which is 1. All on when here the limit of square root of x as x approaches 9, you do direct substitution. So I get square root of 9 plus the limit of a constant is the same thing as a constant equals 1 on square root of 9 gives what? 3 plus 3 which is 1 on 6. Sharp. We are done. We are done. We are done. So let me give you examples to try. Let me give you examples to try. So let me give you more examples. So let's say 3, 4 examples. Then you try it yourself. So that's home link. Another home link on this evaluating limits that contain sets. So they said evaluate the following limits. So the limit as x approaches 2 of x minus 5 all on 2 minus square root of x minus 1. Then 2. The limit as x approaches 2 of square root of x plus 7 minus 3 all on x minus 2. Then 3. The limit as x approaches this point 0 of 1 minus square root of 1 plus x all on x. Alright, so you go and try this question. Go and try this question. We will see. Go and try this question. Try this question. Try this question. Alright, so we've come to an end of this type 3. So that's limit of functions at a point. So we are done with limits of functions at a point. We are still on limits of a functions. We are done with limits of functions at a point. So our next video, we talk of equations involving limits. This time around, they will give you the limiting value, right? So the limit, they will give you the limit of that function, then they will give you the limiting value. Then they will tell you to find for the limit of that function f of x. Our next video, you understand what I'm saying. Alright, so calculus. Alright, so see you. Bye-bye.